So the recording has begun, and today we will continue from what we've done earlier in the classes. In the class, we did what? We discussed, first of all, we started with arithmetic, right? Arithmetic expressions, right? Numbers, operations. Then we talked about algebra a little bit. We're like, all right, look, here's x, the variable. You can do expression simplification, or you can even have an equation, equal sign, right? Solve it. But we did only linear equations. And also later we said, oh, let's do a little bit of inequalities, learn inequalities, let's learn about absolute values. I told us a little bit about factoring and expanding. And here's where we are now. We're going to quadratic equations. So it's so big of a topic. And in fact, for college algebra, typically this is the biggest, like if somebody says, oh, I know college algebra, what do you typically expect them to know? Right here. One second. You expect them to know I'm going to put the, Q in cursive, I mean, I don't know if you care about that, but it's like a 2 looking thing, quadratic. No, you can check that is true. It's interesting though. It's the quadratic, okay, Q, okay, quadratic equation, all right? That's what we're doing today. That's our topic today. You may think, all right, that's all we're doing. Well, there's a lot to it, all right? We're going to do a lot of it. All right, the quadratic equation. So let me begin. First of all, let me give you an equation. What does it mean, quadratic equation? What in the world does that thing, what does it look like, right? It looks like this. What does it mean, a quadratic equation in standard form? So standard form meaning like basically what does it typically want, what do you want to typically make it look like? Or what do you typically expect from quadratic equation? But again, I can have any numbers. So let me explain what I mean by that. Standard form of a quadratic equation is like this. A, that's a coefficient, it's a number, it's a parameter basically that you, like, let's say 5x squared or ax squared, then plus a b, some other coefficient, it's a constant number, like say 3, plus 3x, and then maybe a negative number, positive, like minus a 7, so plus a constant, like a negative 7, and then equals to, you want it to equal to 0. If you're talking about this standard form of a quadratic equation. Why is it quadratic? X squared. If it didn't have x squared, that's linear. We've done that, right? We've done bx plus c stuff. That's last class. We've done more difficult. We didn't have the 0. Okay, anyway, we could always make it 0. Right now, that's standard form of quadratic equation. Let me just quickly say a few things here. A, B, they're called coefficients. Spelled like this. Okay. That's coefficients. X squared, x, what are those? Those are powers of x. Second degree, second power, first power, right? X squared, x to the first. Powers of x. Okay. Like exponents, basically 2, 1, right? And your descending order. There's x squared, here's x, here's nothing really, here's a 1, right? Okay. By the way, 1 is x to the 0th power. Keep that in mind. This is x to the first, and you can put x to the 0th if you like. It's actually just a 1 there. You can get rid of it too. All right. And so c is called the constant term. Okay. And later on, more so than right now, we'll talk about ax squared. The first term, it's called the first or leading term. So that's the whole thing is with 2 being the degree of this polynomial. We'll talk about this later in Unit 3, actually. But this is called the leading term, right? It's the first thing that you have there, highest degree. So leading term. Okay. But really, you want to know coefficients and powers of x, or coefficients A, B, C. Really, I mean, the names are just the names. We want to be able to solve these. So let me give you the first problem we're going to do today. First problem we're going to do today is going to be something where you can you could kind of figure it out without like having to really what is it? To really know anything in a sense. Like let's say let's call it problem A. And I'm going to tell you, look, solve, but it's a quadratic equation. And I'll show you like a way where you can just kind of guess it. Like let's say you didn't learn anything. Or when you learn something, what we do today, the first approach is solving quadratic equations. You'll see, okay, this is really the protocol to doing it. When it gets more difficult, you can still do it that way. You can't guess anymore. Right? So let's do this. Solve this equation here, x squared minus an 8x. Okay, let's solve that, and then let's say it's equal to 0. Let's already have it in standard form. I'm not going to have a constant term here. Notice I don't have like plus anything or minus c. C is 0 basically. Okay, so how do I solve this? This is our first quadratic equation working together. Okay? It's our first quadratic equation working together. So, you know, and I said standard form, right? This is standard form, but let me give you an example. Because I know we're solving, let's slow down just a little bit. Before we solve a quadratic equation, let me quickly give you a problem to how do you put something in standard form before we even solve. So let's do this. Let me give you specifically, how do you find put into standard form, and I'll give you an equation that's a little different. It's still quadratic, but it's different. You have to put it in standard form. So standard form, the following quadratic equation. Okay, write it quickly a little bit. Here, quadratic equation. So look, to do that, here it is. Let's try this one. X plus 2 minus 3x, and then let's try x plus 4 is equal to a 5 minus a 6x squared, and let's do plus a 7. Okay. All right. So how do you put this in standard form, into standard form? And let's do this solving later. Later on. Okay. So to do this and put this in standard form, we would do the following. We would say, okay, what does it mean standard form? I need the 0 on the right side, and I want to do what? To kind of simplify, put like terms together. Let's do this. Let's expand first of all. So x plus 2 times an x right here. Let me actually do that. Right here, 2 times an x, that's 2x. First terms. Outer terms. That's what? That's an 8, 2 and 4. What's a minus 3x times an x? Minus 3x squared. What's a negative 3x and a 4? That's a minus 12x. And that's equal to, all of that is equal to 5 plus a 7, that's a 12. If you see that, right? And minus 6x squared. I'll put these together. All right, right there. Now, we combine like terms on the left side. How many x squares do I have? I have negative 3 of them. Negative 3x squared, that's all. I have just one of those. Then I have how many x's? X plus 2x is 3x minus a 12x. If I put those terms together, I get minus a 9x, right? 3x minus 12x, 9x minus. And then plus an 8, I have it there, right? Plus an 8, that's all I have, is equal to 12 minus a 6x squared. All right. Now, is that it? No, it's not. Let's get rid of this minus 6x squared and the minus 12 and the plus 12 on the side. So look, I'm going to add 6x squared. I'm going to add it under the 6x squared term. The negative 3x squared term, I mean. Take away 12. Take away 12 from the constant. You have, look, finally standard form of the quadratic equation, because you have, look, equals 0, right? Let's cancel. And then this is what? You have 3x squared minus a 9x, and that's what? Minus a 4. 8 minus 12. So 3x squared minus a 9x minus 4. Okay. So we put in standard form, and that's a. What is a? A is a 3, right? That's a little a right there. That's my b minus 9. I'm going to say equals 3. B equals a negative 9, and c is a negative 4, minus 4. And that's standard form of a quadratic equation, right? Quadratic because you have x squared and so on. X term and then constant. Let's solve the first quadratic equation we have to solve. Let's try x squared minus 8x is 0. So what if we did guessing? Guessing and checking. Yes, check. That's not really a method, but I mean, might as well be, right? I mean, it's not really something I'm teaching you, but if you're insightful, you can figure something out. What numbers make this work? How do I get 0 on the left side if it's 0 on the right? Well, let's do this. Let's say x equals 0. Let's check it. What is 0 squared minus an 8 times a 0? That's exactly 0 minus 0 is 0. It works. That's an answer. X equals 0. Is it the only answer? It's not. You can try other numbers. Look, x equals 1. What's 1 squared minus 8 times 1? I get negative 7. Problem? No, right? Not equal to 0. X equals to 2. 2 squared minus 8 times a 2. I get negative 12. Not a 0. X equals to 5. 5 squared minus 8 times 5. I'll get a negative 15 if you are following. Right? 25 minus 40. Negative 15. Not equal to 0. What if I try x equals, 8, for example? 8 squared minus 8 times 8. Hold on, that's 8 squared minus 8 squared, right? You could have seen it, maybe some of you could have. But this is 64 minus 64 is 0. That works. These are the answers. And you know, if you try any other number, if you're not really careful and you don't understand that there are only 2 answers to this one, we'll see why later. What? 0 and 8, and then you can spend forever looking for solutions and you're not going to find any more that work. But we found 0 and 8. We're like, all right, maybe it's 0 and 8. Maybe that's the answer. We're guessing, after all. We didn't really solve it. Now let's really solve this problem. And we're going to learn a little property along the way and whatnot. So maybe let's even have it here as far as what's something we did after all. Right? Okay. Now let's go to solving it the way that I would prefer you solve it. So let's do this. X squared minus an 8x already, you know, in standard form equals to 0. So that's standard form, right? The next thing is, we have it, that's good. Now the next thing is we're going to factor. That's my first approach I'm going to teach you is solving quadratic equations by factoring. Factor. Factor, what are we doing? We have an x everywhere, right? Take it out. So x times, and this is an easy factoring problem compared to some other ones we do, right? And then we have x times x, that's x squared, and then minus an 8. So x times x minus 8. That's giving me x squared minus 8x equals 0. We factored. Great. Then there's a property. It's called, the name is more complicated than what it is, and I'll explain this in a little bit. There's a zero product property. Okay. And so let's do this. Let's first figure out what in the world is this property. Right, we want to know kind of what are we talking about here. So let's see. Let me underline it like this, and I want to say this. The zero product property, it says the following. Take any numbers, any quantities, anything. For example, let's call it A, capital A, I don't know, times a B, capital B. Whatever this is, put in parentheses if you like, multiplying them. Now let's say we have equals to 0. Okay. Well, if two numbers multiplied by themselves give you 0, if I, for example, told you, give me 11 the square root of 7 minus 5, let me do that, watch. 11 root 7 minus 5. After all, I said it, right? Let's do it. All of that, and what if I do, let's do a negative number, negative 0.0281, okay? Let's see. If I do that and I put it in the calculator, guess what? I'll get something if I'm careful with it. But it's not going to be equal to 0. That's all I care about. It's not equal to 0 because this is not 0, right? That's not 0. You'll see it's not. And this is not 0. I mean, after all, it's 0.0281. It's not 0 exactly. It's not 0. So what's the zero product property telling me? If A times B is 0, it's kind of like a common sense thing, right? Then what happens? One of them has to be 0. 0 makes stuff 0. So if this, then A equals 0, that right there, whatever that is, or B equals 0. That's it. There's nothing more to this property. So if that, right? If AB is 0, A equals 0, B equals 0. All right, so let's actually use it here for our equation solving, right? What does it mean, zero product property here? Well, look, my A is this, my B is that, right there. So either x is equal to 0, that's the zero product property there, right? Or what? X minus 8 is 0. That's my kind of B, right? So that's the zero product property. Okay, x equals 0, well, that's what it is. Or x equals 8. Add 8 to both sides. We know how to solve this now, right? That's what? I'm saying 0 or 8. Those are the answers. 0, 8, right? Those 0 and 8 work. We had it up here by guessing, but now we know, well, we're almost there. We almost know that these are the only answers and the answers that work, right? We solved it, and you may think, well, why am I wasting my time in this red stuff? Look, in the purple, right? I mean, it was easier just kind of guess it and feel it out. You'll see why. It's not really you're seeing it now. You see it soon enough, though. Let me show you one idea that's very big. Let's do this. It has to do with the following. Okay, ready? why do I know? How do I know only two answers? So only two solutions, and always a quadratic equation will actually only have two solutions. Because why? Let's see. Because okay. So there's kind of different ways. You can go by contradiction argument. I'm not really particular on you having to know this, but you probably will understand what I'm doing here. So look, because okay, first of all, that is 0 or that is 0, right? Because we have to have equals 0 on the right side. So because 0 and 8 both make 0, and how do we know it's only the 2, right? And otherwise, it's going to be both are non-zero. So both x and x minus 8, I'm going to use a specific case, but anything like that will work, right? Both this and this are not 0, so that the x squared minus 8x will also not be 0. Will not equal to 0, right? And so in other words, if I don't have 0 or 8, it's not going to work for sure. Look, plug it in here. I know most of you understand this, but look, 0, yeah, good. Makes it 0. 8, where is it? 8 goes away. 8 minus 8 is 0. But if I put anything else in, this is not 0, this is not 0. Okay, this is not going to happen right here. That's not happening. So that's the only the reason there are two answers. Okay, that's a little depth there for you. Let's move on to more examples. We're going to have quite a few today. All right, let's go on to another example solving a quadratic equation. A very similar method, but a little more difficult with the numbers. Let's solve the following quadratic equation. 4x squared plus a 3 is equal to 7x. This is going to be a little more difficult to guess. So we're going to probably want to do, actually, we want to probably know how to solve these quadratic equations formally. So let's do this. Put in standard form. 4x squared minus a 7x plus a 3 is equal to 0. Well, let me write one more time, kind of write the steps here. So standard form, remember that's what we want to do here first. Put in standard form. Now, we're going to factor. And if you factor correctly, and if you maybe remember, I think this is very much the same problem we did as factoring exercise last class. Very much at the end. So let's see. How do you factor this? The 2x and 2x did not work, if you remember. It's 4x and x. Otherwise, you get an even number here. And if you try really hard, you're going to get minus 3 and a minus 1 will give you the plus 3 there. And that's going to be a minus a 3x minus a 4x. And that's exactly, putting this together, minus a 7x, which is what you want here, right? It's working. I've factored it. Why do I factor it? Let's say factor. Why did I want to factor? Because now I can use the zero product property to do what? To simplify this a lot. In other words, when I simplify it, I have two linear equations. In other words, a, 4x minus 3 is equal to 0, right? This right here. Or the x minus 1 is 0. And I better be able to solve this by now, right? So I'm like, all right, 4x minus 3 is 0. X is equal to 3 divided by 4, right? Right? Add a 3 and then divide by 4. Or, well, x is equal to 1. All right? 0, add a 1, 1. These are the answers. 3/4 and 1. Now, if you are to check, let's check. Let's just, what if we did make a mistake? Who knows, right? Let's check this. So we will check this. In other words, let's, again, you don't always have to do this, but when you're starting some material, sometimes you want to make sure you're understanding what's going on, right? So check. Let's say x is equal to 1. Okay. Left side. 4x squared plus 3. So 4, 1 squared plus a 3. We can say that's 4 times 1 plus 3. That's 4 plus 3 is equal to 7. Right side. 7 times 1. 7 times x, right? 7 times 1. That's equal to 7. They're equal. Great. That was something we could have probably guessed if we didn't know anything about quadratic equation solving. So like the methods we've learned right now, which is the method we've learned right now is factoring and using the square root, the zero product property. Now look, let's check the other solution. X equals to, what was it? 3/4, I believe. So the left side, okay, let's do that. It's 4 times 3/4, a little bit more of the numbers, squared, okay, plus a 3. That's equal to what? 4 times 3/4 times 3/4. If you try that, you're going to get a 9/4 eventually. The 16 becomes a 4 at the bottom. And then plus a 3, that's a 12/4. I'm getting 21/4. Okay, and I'm doing a little bit faster maybe than some of you want, but that's 21/4. Let's try the right side. It's 7 times x. 7 times x. 7 times 3/4. What do we have? On the numerator, we have 7 times 3 is 21. In the denominator, we have a 4. 21/4. That's equal to that, right? Check mark. We checked. They both work left and right sides. It's working out. All right. So we have the two answers, and we know we don't have to go further because only two numbers can make this 0 and or this 0, or this is 0, right? Nothing else is going to make the whole thing equal to 0 because both are not 0 then. Okay, now, so we checked. That's good. Let's move on. More problems. All right. Let's do one more similar example. Similar to this as far as let's solve the same method a little more quickly. Let's go solve this now. 2x. Let's do 2x minus a 7. And then let's say it's equal to a negative 12. So the numbers look kind of a little bit, different, strange, or whatever. You could divide both sides by 2 right now. Maybe you didn't see that. So let's expand. Let's say you didn't see that. Let's try this. We're trying to put it in standard form first. So we're like, all right, 4x squared, right? 2x, 2x, minus a 14x. And let's do plus a 12. Get rid of the negative 12 on the right side. Equals 0. I see all these numbers are even. Why not divide everything by 2? Let me write, I'm dividing by 2 just so you, divide. You don't have to do this. You can still solve the problem without it, but I think it's easier to do this. So divide both sides by 2, because everything basically by 2, because now we get what? 2x squared, making it look easier for ourselves. 2x squared minus a 7x plus a 6 is equal to 0. I like doing that. I think this is a lot easier to work with. Okay. Now, factor. We know it's 2x times x, right? How else am I going to get? Think about it. How else will I get 2x squared? 2x and x, right? Now, 6, we can try 6 and 1, or we could try 2 and 3. Let me try the 2 and 3, the middle numbers. Let me try maybe a minus a 3 here, because minus, minus, right? How to get a plus, negative, negative, to have a negative here as well. Plus, plus is not going to work. Let me explain. This and this cannot work because this is a minus 7. So let's do minus, minus. Minus 3 and minus 2 will actually work out. Look, definitely plus 6 and 2x squared. This works, this and this. But what about the middle term, negative 7x? I'm just trying to refresh your memory a little bit with how to factor. This outer term material is a negative 4x, right? 2x, negative 2. This is what? Negative 3x. And that altogether is a negative 7x. Let's see, let me do like a double check mark. All right, works. All right, so we factored in the reason we did this is now we can use the zero product property to say that either this is true, that this is 0, the a is 0, or the next number or term or quantity or expression is also 0, can be 0. So we solve this and we get x is equal to, get the 3 on the right side, divide by 2, or we get the 2 on the right side, so x is equal to 2. A lot of times we can write this in interval notation, braces, not bracket, because that's not from to anything. It's just those two numbers are possible, 3/2 or 2. Okay, that's it. That's our answer. Okay? Great. So that's those are 3 problems we did with this method. And so we're going to go on to a new method of solving quadratic equations. Okay? But so I want to do this with an example. I'm going to say, okay, well, let's solve a problem. Call it D. I think it was where it was D. let's solve the following. And you may be surprised as to, maybe this is the easiest problem we've done today. How about x squared is equal to 9? Let's try that one. I think a lot of you right away would tell me, oh, it's 3. Maybe some of you are a little more insightful, like, okay, it could be 3, it could be -3, right? So if we're doing the guessing method, let me kind of call it a method, I guess, if not again. So check, let's call it guess and check. And again, if you're insightful, you can figure it out, right? I know, like, what does it mean? What numbers work? Of course, something squared is 9. That's something x equals to 3. Oh yeah, 3 squared equals 9. Of course that works, yay. What if I try x equals 1? Well, 1 squared is not 9, right? That's a 1. And so, you could try a bunch of numbers, but you can see only 3. Or if you are really cautious, you can see also -3. So 3 or -3, because -3 squared is also positive 9. They both work. And your answer, really, the answer is the only answer you'll have. And the correct one is a -3, 3. You can also say plus or minus 3. That's guessing, and kind of insightfully, you probably know you're right. Let me actually solve it the way that I'm trying to show you here now. It's more of a property that I want to tell you. So first, let's solve it the way we were used to solving it. Okay. What did we do before? What did we just do? Basically, A, B, and C. A, B, and C, the problems we did, what? We did what with it? We said, okay, look, let me make it a little thicker here. Take x squared equals 9 and make it in standard form. So minus a 9 equals 0. I want equal to 0, right? I'm going to factor, and if you're familiar with difference of squares, hopefully, and if you're not, that's also understandable. But it's x minus 3, x plus 3. You can check. Like, for example, you can say, okay, this is x and x, that's x squared. And then how do I get 9 minus? I can do 9 plus or minus 9, and then, minus plus a 1, 9 and -1, but I want to know, I don't want any middle terms. I have 0x. There's minus 3x, there's plus 3x, and that's exactly 0x. That's gonna exactly factor this way. That's equal to 0, we factored. Go for the zero product property, which tells us either x minus 3 is equal to 0, right? Or the other one, x plus 3 is equal to 0. Okay. So x is equal to, from this one, 3, or x is equal to, from this one, -3. Great, we have -3 and 3. Let's do the smaller number first, right? Write it down. Did I do it there that way? Yeah. So that's not where I was going as far as teaching you the new method. That's what we know this already. I actually made it more complicated, seemingly so, right? The new method, the one that I would want to solve this problem with. Now, again, you can always choose whatever you want, whichever method you want to use. But the one I would do is I would teach you a property first. I would say, look, there's such a thing. There was the zero product property. There's also something called the square root property. Let me do that. Square root property. Again, this is also like the wording for all you want. You can say, look, this if a number squared is something, that number is the plus or minus the square root of. Whatever you want. The terminology is not what matters. But square root property, sometimes you'll see exactly these words. It basically says the following. Again, it's one of those things most of you probably don't need this name to kind of understand what I'm saying here. Watch. If a number, call it z, call it something, and let's say it's squared, z times z, and it's equal to some other number, or something, like an n number, right? N for number. Then if this is the case, then what do we know? What does this even mean? Then you know what z is. What is z? That z is going to equal to, typically people say, okay, it's the square root of n, right? But also plus or minus. Negative also makes it happen. So those are two answers. Z is negative. In other words, look, this is z means z is negative root n, or z is positive root n. That's what I'm saying. That's what it means. So that's the square root property. That's it. Hopefully that's not too exciting, but that's because it's z's and n's instead of numbers like x squared equals 9, x is plus or minus square root of 9 is 3, as we're about to do. you probably may wonder, maybe a little confused. But look, actually go back to the problem as far as let's solve specifically what we had. X squared is equal to 9. I gave you that specific problem. And then we already have, it's the square is isolated. So we isolate the square. X squared is by itself. That's the one trick we want to do sometimes that I won't always say, okay, talk about. But isolate the square. Okay, you have x squared is equal to. Now, the thing is here, we're going to do the square root property. And this is very direct. Basically, you already had everything besides. So apply the square root property. What does it say? X is equal to, z squared is 9. That z, which is now x, is equal to plus or minus. Don't forget the minus, basically. The square root of the 9. What's the square root of 9? It's a 3, right? You know that. So x is equal to plus or minus 3. And that means what? That it's negative 3 or it's positive 3. That's exactly the answer we had for both the guessing or doing the factoring. I think this is the fastest way. It's kind of like guessing, but now it's a formal way. It's not even guessing anymore. Using the square root property. It's called actually completing the square, the method. I'm going to write the terminology here lightly, okay? Because completing the square, that's really what the method for solving this quadratic equation would be. Guess what? We already had this done. That's why we didn't really do anything. I didn't call it completing the square. This is the completing the square method. Okay, the most difficult method. Seemingly this problem is easy, but it's really using the most difficult method of solving quadratic equations. Okay, so let's go to figure out what is this most difficult method. Let me give you another more involved example. E. Here goes. Before we do the completing the square, let's still stick around with what we just did, the square root property only. So let's solve. Shouldn't be too bad, let's see, but it's just a little more involved with numbers. 2x squared plus a 36 is equal to 0. How do you solve that? Watch. One thing I could do is I can simplify by dividing everything by a 2. Let's do this. X squared plus an 18 is equal to 0. I mean, you don't have to, but look, I see a 2 everywhere, right? Why not make it easier? 0 over 2 is always the same 0. Isolate the square. So divide by 2, divided by 2. Because everything is even. Isolate the square. I'll say it here. Isolate the square. What does it mean? That means x squared make it by itself. Whatever squared, make it by itself. Equals to negative 18. And then square root property, right here. What do we do? Square root property. We first, if you're confused a little bit, apply it directly. X is equal to plus or minus the square root of that number, whatever it is, and that's a negative 18. Now we do have to be careful with what is a negative 18. First of all, if you have a negative, do you remember that I is equal to the negative square root of a negative 1? I mean, and what does that mean? That means you have a negative in there. Take it out and put an I. So plus or minus the square root of 18, which is 3 times 3 times 2, right? 9 times 2 times an I. Take an I out. So that negative goes right here to an I. And you don't have a 9, you have a plus right there, right? You don't have anything there, negative. Now, it's just simplifying a radical. This is something that, being a prerequisites material. But still, let's make sure we can finalize this problem. Plus or minus, the 3 inside comes out to 1 3 outside, sort of 9 is 3. The 2 remains, and the I is outside. That way there's no negative square root. Okay? That is our answer, which is basically negative root 3i. I mean, it's this, negative 3 root 2i, or 3 root 2i. It's that negative or that positive, right? Plus or minus is that's what it means. Plus or minus. Okay, so that's our solution. Okay, and that's our answer to this problem. That's it. What else do you want to do with that, right? Let's leave it there. Let's go on to another similar one. We're still doing some examples very similar to this one. Then I'm going to go into what I was saying the very difficult thing would be, is completing the square. But first, let's do one more like this, which is, let's say we solve, okay, the following. Negative 5, okay, plus x plus 3 squared equals to 3 squared minus a 6. Okay. what do we do here? Let's simplify this. Isolate the square. I already have a square here. Square. So isolate it. Simplify and isolate the square. And then use the square root property to use square root property. Okay. So that's when you do that. When you can do that, when you can isolate the square, and you can always do that, but it's very difficult sometimes. And that's when that's when I talk about completing the square. The square is already completed for you. In other words, we haven't talked about that, so you may be confused. But in other words, we have x plus 3 squared already as one thing. So look, we look at this and we're like, all right, here's a -5, and that's what's that on the right side? So it's a 3 squared, it's a 9 minus 6. So look, we get x plus 3 squared by itself is equal to, add the 5 to the right side, plus a 9, that's a 3 squared, and then it's a 9, and minus 6, which is equal to what? X plus 3 squared is equal to, and you can see that it's equal to an 8, right? That's, what is it, 14 minus 6 is 8. All this. X plus 3 by the square root property is plus or minus the square root of 8. What is the square root of 8? 2 times 4, which is 2 times 2, right? That's what 8 is. The two 2's come out into 1, 2 outside the square root. In other words, square root of 4 is a 2, right? X plus 3 is equal to plus or minus. Again, these come out into 1, 2 outside the square root, because the square root takes a pair out. If it's a cube root, you take all the 2's out, the 3 2's out. If it's a fourth root, you take groups of 4 out. But this is just groups of 2, because it's really, you can put a little 2 there, actually. If it's a square root, you put a 2 root. You can have that too. It's actually formal also to do that. We don't have to write it. And then look, 2 root 2, right? The 2's left in there. So that's the square root of 8, 2 root 2. Okay, x is equal to -3. Get rid of the 3. We want x. We don't care about x plus 3. So x is equal to -3 plus or minus 2 root 2. So you can do -3 minus 2 root 2, -3 plus 2 root 2. That's our answer. Neat, right? We solved it. As messy as the answer looks, definitely couldn't guess this, right? Like, who's going to guess, oh, let me try -3 plus a 2 root 2? Unless you're really familiar with this quadratic equations, you're not going to do that. So you need a way to solve it. This is a way to solve it, all right? Now look at this. Now I'm going to another problem, call it problem G. But now it's going to demand more. It's going to demand more from us. So here goes. Problem G. Let's solve the following. X squared plus a 16 is equal to 10x. So if I gave you this without saying, anything else, what you would do is actually you could even guess the answer, right? I mean, if you have a multiple choice, I don't recommend it. That's not solving. That's not doing anything that for this class that's useful. But you could do that, or you could do what we've already learned, which is, let me put it in standard form. I'll make it a little thicker here. Standard form, which is x squared, right? Minus a 10x, put the x stuff next, plus a 16 equals 0. This is not the way I want to do. I want to show you to do this, but of course I want to start with something we can do both ways, or all ways. Now look, what do we do here? Factor. If we were to do that, we could. Okay, x, and then what? Minus. How about a minus an 8 here and a minus a 2 here? That works, right? Minus a 10 in the middle, x equals 0. You can check it. This is going to be the same as that. Okay. And then of course 0 product property. X minus 2 is equal to 0. X, let me say or x minus 8 is equal to 0, and then we have x equals to 2, or x equals to 8, right? 2 or 8 are the answers for us, 2, 8. The answer is the solutions are 2 and 8. And that's not where I'm going with this as far as how do you solve this. I'm trying to isolate the square, and the way to do that is we're going to have to learn a new thing here. So I'm going to go to something else for a second, which is going to be completing the square. So maybe call this approach 1. That's I mean, it is an approach. We solved it after all, right? In fact, that was probably the easier approach for this problem. Let's call it approach I. Okay. Now let's try it another way, okay, without guessing. Call it approach I. I. Okay. Lowercase Roman numeral 2 I. Okay. So now, what do? Because we're going to complete the square. So by completing the square. But again, we don't know what that is, so we'll learn it by completing. Let me get rid of this. Completing and isolating the square. So we kind of know what the square thing is. It's basically something squared. And remember, our problem was x squared minus, eventually we put it minus a 10x plus a 16 is equal to 0. We're like, what do we do with a square? What is he talking about? Because here's the problem. We do have a square. Yeah? We're like, all right, we kind of have a square, but let's isolate it. But also a linear term, right? We also have more x. So if I even get rid of this by itself, I'll have this stuff all by itself on the other side together. And how do I solve x squared equals x stuff? That doesn't make too much sense. We don't know that. We don't have a method for that. So also linear term, what do we do, right? I want something squared, x and then blah, 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 squared is equal to something. Remember that number, and then I can do the square root property. That's what I want. But too bad, it's not what I have. Let's learn something new. So we're going to complete the square. We're going to learn that. Completing the square. And one more thing I want to say is get ready for something that may be difficult for, like not easier than anything we've done yet for most of you. I think this method for solving a quadratic equation is one of the most difficult things you even do in this class. Okay, so be patient and gradually enlighten yourself as far as, and I will be also testing you that way, because seeing anything we're doing today is the first time maybe that some of you are seeing this, and of course you can't learn, I think, in a lot of material in just a 1.5 to 2 hour sitting. Just hopefully it soaks in over the weekend and whatnot, but let's see what we can do with with the time we have. Let's do this, and then of course we use the square root property as the other component of this. See right here, we would do the square root property. But look, let's practice some stuff. Let me give you a problem such as complete the square. You'll see what I mean by that. On x squared plus a 2x. What do we do? Right? What does it mean? I'm saying equals to basically what squared? X, and then let's call it plus, and then a squiggle or so whatnot. I don't know what to put here. That's why I put squiggle for now. Let's say. Right? So how do I? What do I do? Look, what if I did x plus squiggle? I'm trying to find that squiggle. If you remember maybe in algebra class where you did weights, and it's like 2 plus what is 5? 2 plus x is 5, and you put like a little 2 pounds and 5 pounds here, and you want to scale it out. So you need 3 pounds to make it, right? 5 is 5. So look, here's a squiggle. We don't have no idea what it is. Let's say x plus squiggle squared. I'm going to do that is what? It's equal to x plus that squiggle times x plus the squiggle. Let's just remember what the square means. It means, multiply the same thing by the same thing. Multiply it out, you get x squared plus, look, the outer terms, x times squiggle, plus the inner terms, squiggle times x, plus a squiggle squared, right? As awkward as it looks, or silly as it looks, while I'm doing this, I think it's going to help. Watch this, x squared plus a, this is, you can rotate them, right? 3, 5, and 5, 3 multiplied, you can flip them around. 15 is 15. So how many of these squiggle x's do I have? I have 2 of them. Okay, I have 2 squiggle x. Okay. That's that one, these put together, plus a squiggle square. Don't forget there's a squiggle square there. All right. The goal for me now is to match this up with, I have to have this match up with x squared plus a 2x. You see there's a 2x right there? Okay. Somehow I have to match it. So how do I match it? Well, x squared is already matching right here, right? How do I get 2 squiggle to be 2? Squiggle should be 1 in this case, right? 2 times 1 is equal to 2. Since 2 times squiggle being 1, 2 times 1 is equal to 2 is what we want, right? Okay, so squiggle is 1. Basically, I'm saying this. Check x plus 1 squared. It's going to be, if you really multiply it out, you get x squared plus a 2x. Yep, you'll get a 2x. And then it's also plus a 1. So when I ask you, let's go back to that problem. Let me do a little color change here. I think it's going to confuse you if I don't. Let's do that. Let's see if it works. Let me try something. Let's see this. Okay. All right, so let's do something you can kind of see color. That's still not thick enough. 1 sec. Okay. So, all right, 1 second. Let's do this one. Okay. So now you have x squared plus 2x. Anyway, we're trying to match that with something, right? So x squared plus 2x. Now let me do that. X squared plus a 2x. That's what I was telling you. Kind of complete the square on it. Meaning, you see this is what I want. That's where it is. And you know what that is? Solve for it from using this equation. It's going to be x plus 1 squared. Right, it is. But you have a get rid of that 1. How do you get rid of that 1? You get it on the other side. So minus a 1 here. Right? That way I get rid of that one. So minus 1 squared. If you check this, these are exactly, I'm going to underline the same thing. So this underlined right here is the same thing as this underlined right here. All of that. We completed the square. That's what you would do. I'm going to show you another example. So that's that. Kind of probably didn't make too much sense as you have seen it the first time only. Let's try more. Let's try x squared plus a 6x. What do you do here? I need x plus something squared. Guess what? I'm going to have that squiggle, 2 of those squiggle, whatever that squiggle is in here. I'm going to have 2 of those x. What's half of that 6? It's a 3. I put a 3 here. That's how you get 6x, 3x, and 3x. Okay. Now, maybe you'll understand this better soon enough. And then take away, remember, you're going to have a 9, a 3 squared over there and somehow. So take away that 3 squared. In other words, it's x plus 3 squared. You can check this if you want outside class. Okay. X squared plus 6x plus 9 minus 9. This is exactly the same thing as all of this. Just another way to write it. Let's do more examples. I'm going to do specifically these. So that's another, we did this one, right? X squared plus 2x, x squared plus 6x. Let's do another one, x squared. Let me show you. Let's do x squared minus a 14x, a little messier with a number, right? How do you do this one? Well, it's x, and then what's a negative 14 half divided by 2? How about a minus a 7? Because then you get negative 7x if you square it, and that's going to be negative 14x. But you have to take away a negative 7 squared, which is also a positive number. Doesn't matter, negative or positive. It's x minus 7 squared minus a 49. And I'm doing this much more quickly now, as you can see. So match these up. We're going to do a few more of these examples so you get really a little bit more familiar with this completing the square. I did that one really quickly, I think. X squared minus 14x. X minus half of the 14 is a 7. You square it, take away that 7 squared. Okay? That way that matches up exactly. Now let's do this. X squared plus a 5x. How do you divide a 5 by 2, right? Well, I mean, it's not like we can't. It's going to be 2.5, right, or 5 halves. So x plus the 5 halves, okay, divided by 2 to 5. 14 divided by 2 negative is a negative 7. 5 divided by 2 is 5 halves. Can't do much more with that. You can do 2.5, but I prefer improper fractions. So you have this. Take away that 5 halves squared. Remember I told you, get rid of that last number because you're not going to have that right here. You don't have anything there. Get rid of it. So squared. And that's going to equal to, again, just copy this. And then minus, what is it? You'll see some homework problems where it asks you for the little n. And it's going to be 5 halves here. Where, anyway, this is, what's 5 halves squared? 25, right, on the top, 4 on the bottom. Okay, that's that right there. You can check this. I think a good way for us to understand this better. For some of you, check if this and this are exactly the same. You can do this at home. It will work. Okay. Let's do last one. Let's do the last one of these, and you'll see why I'm specifically choosing targeting this x squared minus a 10x. And I think this is easier than the last one. How do you do this one? X, what's half of the negative 10? Minus 5. You square it. You take away the 5 squared or the negative 5 squared. It's the same thing as squared is going to be a 25. Okay, now, we mash these up. Why did it even do this? Go up here for a second. Look at the red solution. We're stuck with, here's a square and here's not a square. What do we do with all this? X squared and negative 10x and all that, right? Let's get this problem again. And we write, what is it? It has the same stuff. Look, x squared minus a 10x. It had a 16, of course, had a plus 16. And set equals to 0. Here's that underlined x squared minus 10x. Here's that underlined x squared minus 10x. I'm going to substitute for x squared minus 10x what I have on the right side here. I'm going to have that. Let me do the little double underline. It's the same thing. So I'm going to do x minus 5 squared minus a 25. Okay, I'm going to do the same. I'm just going to make it look different. That's all I'm doing. Right there. They're equal. Okay? And plus a 16, I mean, I have it, equals 0. But guess what? I completed the square. Now let me isolate it. So this is completing the square. Completing square. That's what that is, that method. That's what we did. And the reason we do this is so now we can isolate the square. Isolate the square, and then we'll use the square root property. So here goes. Isolate the square. We get x minus 5 squared is equal to, what's 25 on the right side minus 16? Positive 9. We can check, get rid of these numbers, put on that side. Okay. What do I do now? Square root property. Square root property. Why is this not so bad anymore? Look, x minus 5 by itself, right? That's like the z, is equal to plus or minus, and we know this is plus or minus square root of 9 is 3. In other words, x minus 5 is equal to negative 3, or it's positive 3. Okay. Solve, right? Add 5 to both sides. Do that. X is equal to, what's a negative 3 plus 5? It's a positive 2. Or x is equal to, what's 3 plus a 5? 8. Here it is. Guess what? That's what we had. Regardless of what we did, this problem, we had this answer right here. We did. That's that. So we have a new way of solving. We do. Let's try problem H. What do I have here? Problem G. Let's do H. More problems. And we have a lot, not a lot more, but we have some more material to cover. And today is a very intense day for us, I know that. So G, let's do this. Now let's do H, right? But you know what's nice is that I'm going to just do the same problem sometimes over and just in different ways. So let me actually take solve, and I'm going to take the same one we've done. 4x squared plus remember it was a 3 equals to 7x. But I want to do this now with a different method. So remember I did put in standard form, and I had what was it? I had 4x squared. You can see minus a 7x plus a 3 is equal to 0. Great, we have standard form. Right? Let's do what? How do we use completing the square method? First of all, I like x squared, right? Look at this. Every one of these dotted ones, x squared minus 10x, x squared plus 5x, x squared, right? I want 1x squared, not 4. Divide everything by 4. That's the ax squared divided by 4. You get just x squared. Unfortunately, that becomes a negative 7 over 4, whatever that is, 7/4, right? 1.75. But it's 7/4, and then plus a 3/4. I divided everything by 4 equals 0. I don't think it looks nice, but at least we're ready to complete the square. We're going to complete the square. Here goes. X, what's half of a negative 7/4? It's a minus 7 over 8. Divide by 2. Another 2. I mean, Not that it's easy to understand what what's 7/8. 0.875 if you use a calculator. That's what it is. You divide it 7/4 by 2. You square it. You take then you're taking care of all of this. Besides, you also have to take away, remember, 7/8 squared. Remember, take away 7/8 squared. And it says, of course, plus a 3/4. I mean, it says that equals 0. Let's isolate the square. Let me just go ahead and do that and simplify. So x minus 7/8 right there, and I'm squaring it, right? And that's equal, and by the way, this is a minus a 49, I mean, over 64. That's what 7/8 squared is. Plus a 3/4, right, equals 0. What is 3/4? It's, let's make sure we get the common denominator. Let's do 64 at the bottom. So x minus 7/8, I'll show you what I mean by that. So that 8 squared. Let's get rid of this. 49 over 64 on the right side. I'm getting this over there and this over there. Minus a 3/4, which is minus a, if you look at it, it's 48 over 64. Okay, I multiplied top and bottom by 16, just to get a common denominator of 64 right there. I want the same thing. But the top also has to be multiplied by 16 if this is bottom, right? Because I don't want to change 3/4. All right, now, what's 49 minus 48 over 64? It's 1 over 64. We're very lucky to have an easy number. We do what? The square root property, and we get x minus 7 over 8 is equal to plus or minus, what's the square root of 1 over 64? That's 1 over 8. Okay. Let's see how, remember, we solved this problem before, and we may not remember the 7/8 plus or minus 1/8. Let's look at, let's add 7/8 to both sides. So x equals to 7/8, and let's do minus 1/8, or it says x is equal to 7/8 if you add the right side, and then plus could be plus a 1/8. In other words, x is equal to 6/8, right? What's 6/8? That's 3/4, right? 3/4. Or x is equal to 8 over 8, which is equal to just 1. 3/4, comma 1. That was the second problem we did today with quadratic equations. We solved with factoring the problem 4x squared plus 3 equals 7. We even checked these answers. Look, 3/4 and 1. Let's go all the way up for a second. And we get this problem. Look at this. Where was it? Right here. 3/4 and 1. Double underline. No, we solved it. But this was the easier way. I think this is much easier than what we just did. So why did I do what I just did? The square. Why you ever do the square root property, completing the square? A square root property, we can see kind of that helps sometimes, right? X squared is 9. Oh, plus or minus 3 right away. Completing the square, however, took some energy from us. Yeah. So there's a reason I was doing all that. Of course, let's see. Let's go ahead and now look into something that could be, if you like, I know college algebra, if you say that, here's the result that's like the biggest result that you know and eventually you memorize, regardless of how messy it looks. Not the proof. I'm about to do a proof. I'm about to give you a really thorough explanation of, but at least if you follow along with the proof of what I'm about to do, I'm going to call it what it is afterwards. But I'm not, like, some of these steps for showing the work a little bit too much maybe for what I would expect from you, but at least the result, what we get from what I'm about to do, that's going to be hopefully very useful, and you probably will eventually, after using it, will remember it. So let me go ahead and do this. Let's try this. Let's do this here. So let's look at this. Okay. Let's take again the quadratic equation in standard form. Ax squared plus bx plus c equals 0, right? That's our quadratic equation in standard form. Let me make it a little smaller here. Okay, let's do that. Okay, now this is, again, what I said is a standard form. So I'm just going to write that one more time, a few more times, if not the last. And then what can I do with this? What did I do for that last problem? We're going to do the completing the square on this to get some. We're going to solve this. Any A, any B, any C, we want something that works. We want a formula that works. that, we get an answer. Now, if you give me A, B, C, I later plug it in. I don't have to think much, and I get it. I get everything I want. So look, here's what we do. What did we do last problem? I had a 4x squared, and I made it just an x squared. I divided by a 4. Let me divide by the A. Divide by A. So x squared, right? Correct? And then plus a what? B over A, x, right? I mean, that's what it is. Divide by A. Plus a C over A, and then equals 0 over A. That's just 0. Okay, now this is where we're going to right away go into completing the square. So far the same, so good, right? Same problem. Complete square. So going on to this next part, this is the most difficult part. We look at these terms here. I'm going to underline this x squared plus a b over ax for a moment. That is exactly, look, x plus half of the b over a, remember? We half it. Is b over, well, it's 2a. You have 2a at the bottom. Okay. You square. And then, well, you take away that square, that term squared, because remember, we have to get rid of it to match. So this and this has to match. Currently, this and that right there, let me show you again. This and this do not match. Why? I'm adding a b over 2a squared in here. That I don't have anything there right now, right? So take away b over 2a squared. Okay, and that may be very confusing for a lot of us, especially with b's and a's and c's and not numbers. And of course, plus a c over a is equal to 0. But again, we just completed the square. That and that are the same. Okay, that's where I was going with that. So that's why we worked so hard on completing the square. Maybe some of you understand this. If you don't understand this proof of what I'm about to do, at least remember the result and know that it wasn't difficult. It was not easy necessarily for everyone to really get there. But I'm not going to ask you to do these steps again. So what I'm doing now, just a little bit more optional, but hopefully helpful. So look, this is completing the square. Let's isolate the square, remember? So we do x plus b over 2a. See, it's by itself. Well, eventually it will be, yeah. So how do you make it by itself? Add the b over 2a squared to that side, and subtract the c over a. Okay. Now we isolated the square. Let me write that isolate square. Then we're going to just simplify. From now on, we're going to simplify and solve for x. How do I simplify? Keep the square by itself. We isolated it. Everything with an x and it's squared. But at least we don't have like x squared and x by itself. We have x blah 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 blah, and it's just squared. It's all together. We can then use the square root property soon. Let's simplify this right stuff. So simplify, and we get what? Let's see. Let's do fractions. This is very big to be able to do these fractions. This is b squared. If you multiply b times b, and what's over 2? What's 2a times 2a? 4a squared. Minus, it says minus a c over a. How do I get a 4a squared also for that one? How about times 4a here and times 4a here to make these the same? Okay. So I'm going to just write this again. B plus a 2a, x plus b over 2a squared is equal to b squared minus a 4ac. See that one right there? And then, of course, they're all over 4a squared, right? That's the common denominator. So make sure you understand that from here, we're getting to all this. Where I made this, that's why it's 4ac. That exactly is that right there. All right, what do we do with this? Now we square root property. We use the square root property. Square root property. That's really that's it almost. So with these steps, so we're learning these steps, we can do everything. Watch. X plus a b over 2a. Get rid of the square root. Or the square, I'm going to take the square root. But remember, plus or minus. Plus or minus. Copy that. Let me actually just copy it. Watch. Copy, paste. Write it right here. But make sure you put, remember it's a number, you put the square root of it. And almost have a nice answer here. It's a property. It's a formula actually. I'll tell you. So look, it's x, get rid of the b over 2a on the left side, so minus a b over 2a. And if you simplify this, it says plus or minus. Let's get rid of let's keep the square root on the top. And what is that? That's b squared minus a 4ac all over. What's the square root of 4a squared. Remember, we even got that from 2a times 2a. It's 2a. I have a common denominator already. That's not bad. We're getting the final result right now. Watch this. I'm going to make it as neat as possible. That's pretty big as well. X is equal to negative b plus or minus, this is the numerator, b squared minus a 4ac all over, okay, the denominator is 2a. Yeah, this is such a big result. This is the algebra, like college algebra result, that you really, as ugly as it looks, you will have this memorized by the end of class, more than likely, just because you'll be solving problems so much using this. You'll like it. It's going to actually be like a kind of like a tool to help you, not have to think much sometimes. Like, especially imagine in real life, you have a calculator, right? What do? Just use it, plug the numbers in, and be careful, right? So I'm going to box that. I'm going to call this, the result is, it's the quadratic formula. That's what this is. I'm going to call it all caps with printed. Quadratic, okay, formula. Yep, that's what it is. That's our quadratic formula. That's, yep, exactly what it is. All right, we found the quadratic formula. We actually didn't just guess it. I mean, it wasn't just something like, oh, memorize it. Now, that's all I'm going to ask you to do is really, you have to know this eventually, okay? Be patient with it. I'm going to be patient with you. Be gentle on yourselves. I mean, I know, like, if you're the first time you're seeing this ever, or if it's, you haven't seen this in a long time, at least just be able to use it if, but, eventually you have to memorize this and you will have it down, but after so much practice. And class continues because we still have some material to do. So today is a very, you can see this is a very big and intense day. We're going to go to problem I, not 1, but H and then I. And we're going to use this quadratic formula. So, because right now it looks kind of ugly, right? Like b squared minus 4ac, right? All that stuff. Watch this. Let's put this to use, and then you'll kind of understand. This is probably the nicest result you're going to get in this class, because it's going to help you a lot. It's actually going to be more helpful than hurtful. Let's solve an equation. We've done this one already. X squared plus what is it? Plus 16 equals 10. Remember, we had the exact same problem, 10x. And what do we do? And we want to use the quadratic formula. What do we do? Well, first of all, we want to find it in standard form. So x, one second, x squared, right? And then minus, we did that already, minus a 10x plus a 16 equals 0. Putting it in standard form now, there's not much left to do as far as initiating the quadratic formula. We need to know the a. A is equal to, how many x squares do I have? 1. How many x's do I have? Negative 10. The b is a negative 10, and c, the constant, is a 16. Quadratic formula. Let's say we didn't remember it. Let's take this one. Let's copy it. At least I'm going to do that. Okay. Paste it here. Bring it over here. Make it very small, or much smaller. And let's solve for x. Let's using this formula. Should always work. This formula always works, regardless of imaginary, square root of negative, square root of 0. It's okay. It's going to work. It's going to be the correct result. So equals to, what's negative of a negative 10? See negative b? Positive 10. So equals to 10 plus or minus. Plug in the numbers in correctly and carefully. Negative 10 squared, 100. Minus 4a is a 1, c is a 16. Plug in the right numbers in the right spots, carefully add, subtract. That's the only issue sometimes the students having a difficulty with the arithmetic. That's why we're practicing that a little bit too. 2a, that's 2 times 1. Let's continue. It's 10 plus or minus the square root of, what's 100 minus, that's a 64. 4 times 16, okay, positive. And then all over a 2, that's equal to 10 plus or minus the square root of 36. That's going to be a 6, isn't it? Plus a 2 equals to 10 plus or minus 6 over 2. What is that? So x is equal to, let's do 10 minus 6 over 2. Let's do maybe x is equal to 10 plus 6 over 2, right? Let's see what that is. That's equal to 4 over 2, or x is equal to a 16 over 2. What is 4 over 2? That's a 2. 16 over 2 is an 8. X is equal to 2, or x is equal to 8. Woohoo! Why that? Because we knew that's the case. We solved this problem already in different ways, completing the square even. Right? Or, yeah, no, did we do this one completing the square? 2, 8? Let me see. Did we do that last problem? Yeah, we did, right? That was the first one we did with completing the square right here. 2, 8, we got that, and we had it earlier. We factored it. We got a x minus 2, x minus 8. 3 ways we have done this problem. We get the same result. Probably we're right in the 2, 8. We even checked, right? It's 2, 8. Or we didn't check this one. But you can check left and right side, you'll get 2. Put it in, you get the left side and right side are equal. Put 8 in, it's going to be equal. And then every time you put any other number in, it's not going to work. So we do this. We use a quadratic formula. We got it. Let's do problem J, just to kind of get familiar more so with this quadratic formula. Let's do it again, but on another problem we did today. So J, let me kind of be gently say this is going to be the last problem we'll do today. So just kind of, and I know if you're really like overwhelmed by now, we've done a lot. I would say a lot on quadratic equations. I told you only one topic, right? A lot to do. So anyway, let's solve our 4x squared plus a 3 is equal to 7x, using the quadratic formula this time. That's our third way. And you'll see this is not so bad. At least not that crazy completing the square, right? Where we have to divide by 4, what is it, x, and then minus that 7/8 squared, right? Look at this. Standard form, 4x squared minus a 7x plus a 3 is equal to 0, right? Now, what we do is, we don't have to divide by 4 or anything. Look, we just have a is equal to 4, b is equal to -7, and c is equal to 3. Then what? Let me actually do this. I'll paste this quadratic formula in here. Let's use it. You may not be familiar with memorizing it yet. So let's use this. And then this is what? Let me lower it just a little bit. Looks like equal sign there. Okay, let me just lower the equal sign. So that's equal to negative b. What's a negative of a -7? Positive 7. Plus or minus. Square root of 7 squared or negative 7 squared, same thing. It's 49 positive. Minus a 4 times the 4a times the c, which is 3. We have this. We divide it all by 2a, which is 2 times 4. That's going to be 8. Equals to 7 plus or minus the square root of what's that? 49 minus 7. If you check it, it's 48. Right there. What? 4 times 4, 16 times 3, 48. You know what this is called? Just on the side note, let me do this in a highlighter. Okay. That is called the discriminant. You'll sometimes have problems in that, like on your homework. Discriminant, and it may say, what's the discriminant and how many, that's b squared minus 4ac, and how many solutions there are. If you have 3 cases, just a kind of heads up, it's not going to be something we're going to do right now, but it's basically, you'll understand from what we're doing. If d is positive, you have 2 real solutions, 2 distinct real. If d is equal to 0, what's plus or minus 0? It's the same thing, right? 1 real solution. Not a problem though, square root of 0, 0. But d is negative, we have imaginary numbers, right? Square root of a -1, I mean, that's a problem. Calculator is going to give you error. We're going to say 2 non-real. 2 distinct non-real. Okay, if you have your homework, you'll understand based on this. But let's go on to finishing this problem and calling it class. So 7, all that, right? Plus or minus the square root of 49 minus 48. And then all over 2 times 4 is an 8, right? Here we are. 2 times 4 is an 8. Let's write this as 7 plus or minus. What is the square root of 1? That's a 1 right there, right? That's our discriminant. That's why we're going to have 2. 1 is greater than 0, right? We're talking about this case for our problem. It's going to be 2 real solutions. And we know this problem had 2 real solutions. We knew what they were, actually. If you look up, or if we're about to get. So 7 plus or minus 1 all over 8. quick recap is that, look, 7 plus or minus 1 over 8. Remember how we completed the square, not quadratic formula. We completed the square, and we got, you see that 7 plus or minus 1 over 8? That idea, it was there. And remember, how come? Quadratic formula, we got it from completing the square right here. We used that trick. That's why it's kind of implied in there, but we just memorize a formula. We don't have to do much more than that, right? So look, we have 7 plus or minus 1 over 8. That's the answer. Besides, let's simplify it. 7 plus 1 and 7 minus 1. 7 minus 1 over 8, or 7 plus 1 over 8, right? Oops, over 8. And what is that? That's equal, so x is equal to 6 over 8, which is 3/4, right? Or x is equal to 8 over 8, which is exactly 1. The answers are 3/4 and 1. And this is what we resulted with every time. We factored, we got it, the zero product property. We completed the square root property, we got this. That was the toughest approach. Yeah, it was. And then this is a quadratic formula. It gets 3/4 and 1. We don't have to worry about the factoring if it's correct or not. We just have to make sure the numbers, we don't mess up on computing the numbers. Okay. With that, I'm going to call it, enter the recording for sure.